Today we're going to talk about sine and cosine functions. Now, before we get much further, okay, I have here an equation of a circle, and I have some generic point x comma y. The equation of a circle is x squared plus y squared is equal to r squared, okay, r being the radius of the circle. If it happens to be a unit circle, that radius would be 1, but not every circle is a unit circle. Sine of theta is defined as y divided by r, and cosine of theta is defined as x over r. Okay? So if the terminal ray of an angle in standard position passes through the point 4 comma negative 3, find sine and cosine. Okay, so first thing I'm going to do is draw a picture. 1, 2, 3, 4. 1, 2, 3. Okay. Now, that means this side is 4, this side is negative 3, and I need the hypotenuse. I need that r squared. So again, told me x squared plus y squared is r squared. It's really just the Pythagorean theorem, okay? And you can see it in that I've made a right triangle. It's the Pythagorean theorem as well there. My x is 4, y is 3, 16 plus positive 9, because negative squared is positive. R squared is 25, so r is 5. When I go to find, again, my x was here, my y and my coordinate point. So sine of theta. Notice here I still have my angle there. It's not just sine equals, it's sine of theta. Is negative 3/5. And cosine of theta. So go ahead and pause the video and try example 2. Okay. When you do example 2, though, make sure that you reduce all of your radicals. No, write the decimal approximation. Reduce the radical instead. Did you finish example 2? Did you try it on your own? Go ahead and pause it. It's okay. I'll wait. Alright, so start my picture. Negative 2, 3, 4. Triangle. I'm going to do the Pythagorean theorem, which is really all circle equation came from. And remember my positives. So r is the square root of 20. And the radius is always going to come out positive, so you don't have to worry about the plus or minus when I square root. When I reduce the square root of 20, that's square root of 4 times square root of 5. So 2 root 5. So sine of theta is going to be 4 over 2 root 5, which is 2 over root 5. So if I don't have to rationalize, the directions weren't clear here, I could leave it like that. Or if I rationalize, I could have 2 root 5 over 5. Cosine of theta, negative 2 over 2 root 5, negative 1 over root 5. Or if I'm rationalizing, negative root 5 over 5. When I'm rationalizing, I'm just multiplying top and bottom by that radical 5 to get the radicals out of the denominator. At this point, it's okay sometimes to leave the radicals in the denominator. I'm not as picky about that as you had seen last year in Algebra 2. Sometimes, even in calculus, you work to get the radical in the denominator instead of out of it. So from geometry in Algebra 2, we know sine and cosine as SOHCAHTOA. All right, where sine of theta is opposite over hypotenuse, cosine of theta adjacent over hypotenuse. And tangent of theta is opposite over adjacent. What we're looking at here is in a right triangle. This is my angle. This would be my opposite. This would be my adjacent. It's right next to. And this is my hypotenuse. If you're ever not sure which one's the opposite, put your finger on the angle and the side your finger's not touching, that's the opposite. Now, if I go back, we just defined sine as something different than opposite over hypotenuse. Let's go back for a moment. So this is, and I drew it in second quadrant, but you could draw it in any quadrant. This is x and this is y. Opposite, and my hypotenuse is that radius of my circle. So this y over r that we defined earlier, that's really just opposite over hypotenuse. And x over r, well, x is the one that's right next to it, so that's my adjacent over hypotenuse. So this is all just applying the Pythagorean theorem and SOHCAHTOA. So if I had x is my angle here in this one, I'm going to start by finding my 90-degree angle in it. My last side will have 10 squared plus 24 squared equal to r squared. You could also call it c squared if you wanted. So my opposite, my adjacent, and my hypotenuse. Sine is opposite over hypotenuse. And then I'm going to simplify this and I'm going to get 5/13. So you could math frac that if you'd like. 24 over 22, which is 12/13. And tangent 10 over 24, 5/12. So theta is a third quadrant angle. So that means I'm going to draw my picture. So the quadrants, just as a reminder, this is my first quadrant, my second quadrant, my third quadrant, and my fourth quadrant. So we start in that first quadrant where x and y are both positive, and then we rotate around counterclockwise, just like how angles rotate counterclockwise. So third quadrant angle. And they tell us what sine is. So if sine of theta is x, I'm going to move the negative up onto the top because that, remember, that denominator is the radius. So this is y over r, or you can think of it as opposite over hypotenuse. No option's going to work for you. Okay. But I moved the negative to the top because we want that radius to be positive. So this is my hypotenuse, 13, or that radius being positive, and then my opposite, or my y value, is over here, right here, and that length is going to be -12. Okay, notice the negative. The negative is accounting for us being in the third quadrant, and that it's headed down. Find cosine. I'm going to have x squared plus 12 squared, 13 squared. So here I get x is plus or minus 5. It's only going to be one of those options, and when I look at my picture, because I'm in the third quadrant, this is to the left. That's why it's going to be -5 and not a +5. The cosine of theta is -5 over 13. So as I look at angles, because here is my theta, notice theta is not in that triangle. It's larger than that triangle. It's actually a reflex angle. It's bigger than 180 degrees. That's important thing because my cosine value is coming out negative. Theta is a fourth quadrant angle, so I'm going to be down in quadrant 4 over here. And sine of theta is negative 7/25 to find cosine of theta. So go ahead, try this problem. I just drew where it's going to be. Pause the video. I'm going to leave that one for you to do. Okay, so you can check the work, the answer key later. So as we're working on this, sine of theta, again, is y over r. And cosine of theta is x over. We can determine whether sine or cosine is going to be positive or negative based on which quadrant we're in. So since r in both cases is always positive, we're going to look at those numerators to tell if sine is going to be positive or negative. The two quadrants where y is positive is the first quadrant and the second quadrant. In these bottom two quadrants, quadrant 3 and quadrant 4, the y values are both negative. Cosine is positive when x is positive, which is in quadrant 1 and in quadrant 4. It's going to be negative over here because all of my values on this side of the circle have negative x values. So sine of theta is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. Cosine is positive in quadrants 1 and 4, and it's negative in quadrants 2 and 3. So which quadrant is both sine and cosine negative? Well, both are going to be negative in quadrant 3. Which quadrant has sine greater than 0? So that's saying positive. And cosine less than 0. So that one's saying negative. Go ahead and look up to my charts. Where is sine positive but cosine is still negative? Quadrant 2. Right. Without a calculator, which is greater? Sine of 178 degrees or a sine of 182 degrees? Well, I'm going to need a picture. So sine of 178 is almost 180. So there's 170. So you can see how it's this little tiny value? Okay. Now, 182, I'm just going to draw it in red. It's like a little sliver on the other side. See how it's past that and it's into quadrant 3? This value is in, that angle is in quadrant 3. So sine of a quadrant 3 angle is going to be a negative value. 178 is in quadrant 2, where it's going to be positive. So if I know one of them is positive and one of them is negative, sine of 178, even though I don't know what the actual value is, has to be the larger of the two, positive. Now here I have cosine of 5 pi over 4 and cosine of 7 pi over 4. Here I have it in radian measure instead of degrees. Okay, I can still answer this question though. Go ahead and try this one without a calculator, and again, for radians instead. Okay, so 5 pi over 4 is over here. 7 pi over here. So this is a quadrant 4 angle, where cosine is positive. And this is a quadrant 3 angle, cosine is negative. Cosine of 7 pi over 4, being the positive value, has to be larger. So we had this circle already, but here I have labeled with degrees end with radians, and I have it beautifully color-coded. Okay. I want to add a couple of coordinate points. So we're going to call this a unit circle. Okay, and if it's a unit circle, that tells me it has a radius of 1. So I'm going to add some coordinate points on this. Right here, this coordinate point is 1, 0, because we're going to put the center here at 0, 0. And this is moved 1 towards the right. Up here is going to be 0, 1. At pi, it's going to be negative 1, 0. And here at 270, or 3 pi over 2, 0. So we've added 4 coordinate points onto our unit circle. Okay. There are a bunch of other points on this unit circle, but those are the ones we're going to focus on today. So now we're going to solve these equations. I'm going to solve the first two, and then you're going to solve the others. So, and first thing I noticed when I read my question, it says from 0 to 2 pi. That's telling me I want to be in radian. Okay, so my answers are going to be in radians, not degrees. So remember, sine of theta is equal to y over r, and cosine of theta is x over r. Since I have this as a unit circle, my r's are automatically 1. Okay? So this is asking me if my fraction's equal to 0, my y must have been 0. So what coordinate point on my unit circle does the y value have 0? Well, I have a 0 for my y here, and I have a 0 for my y here. So it actually had 2 answers. And so we would say x is equal to 0 or pi. It actually would have 2 pi as well, but if you look at my descriptor, it has 0 to 2 pi with a bracket on the 0 and a parenthesis on the 2 pi. That says not including 2 pi. So while 2 pi is coterminal to 0, and I could keep going and listing out an infinite number of options here, I'm not going to include 2 pi. All right. I'm going to do the other sine one, and I'm going to leave the other two for you, the 2 cosine ones. So second problem says, when is sine of x equal to 1? And the only way that this fraction is going to equal 1 is if y is 1. I'm going to go look at my circle again and find somewhere where the y value is 1. And that happens at pi over 2. And so we're going to say x is pi over 2. There is only one answer. That's it. So I'll leave the 2 cosine problems for you to finish off. And this concludes our lesson on 7.3.